This is Tech Math 2. And we are in section 7-4. And a quick look at the syllabus would tell us that tomorrow we review for a test, and on Friday we're doing a chapter 6 and 7 test. 6 and 7.
Also, if anybody wants, I have an extra calculator, a key
On Friday.
I-83, if anybody wants one, let me know. I had to find the TI-89.
So you finally went and bought the right calculator? All right.
Well, that's what I originally wanted to buy, but Iowa Western didn't have that. I didn't have the cash.
Oh, typical.
Freaking out Western.
Yeah, a bunch of hosers anyway. Anyway, so
It's all Iowa.
Oh, all of Iowa's that way? Oh, I don't know. Yeah, probably. Yeah, exactly. It must be so. In the previous chapters are solving quadratic equations. In this one we do too, but we don't have the equation, so we have to make it up. So we'll start with problem number 1 and hope for the best. Separate 13 into 2 parts whose product is 40. All right, so I've got, so A plus B, 2 parts, is 13. And so A plus B is 13, and A times B is 40. All right, so now I got my 2 equations, my 2 unknowns, and can I put it in my calculator and solve it?
8 and 5.
8 and 5? All right, so A is equal to 8, B is equal to, so we can just look at it and know the answer is what you're telling me? All right, yeah, probably. That'd probably be the best way to do that one. Or it could be the other way around. It could be A is equal to 5 and B is equal to 8, right? It could be that way. So if I wanted to do it different than just look at it and know the answer, how would I do it? Oh, I'd probably say that A is equal to 13 minus B. And then I'd say 13 minus B times B is 40. I'm not doing well at all in separating my stuff here. And then I'd have minus B squared plus 13B minus 40 is 0. And then I'd factor that. And because I already know the answer, I would probably factor it minus B and B and plus 8 minus 5 is 0. And then I'd say, well, clearly B is equal to 8 and 5, right? 5 comma 8. Which I already knew because I guessed. Well, it wasn't a guess. I just knew it. It's not a guess if you know it, right? It's only a guess if it's wrong and you didn't know it. Yeah, exactly. All right, well, that seemed all right. Rectangular plot, rectangular field. Number 7. Oh, we have to do 3 first, so we'll do 3 next. Number 3. The length of a rectangular plate is 3 centimeters greater than twice the width. Find the dimensions if the area is 335. Okay, so the area, which is length times width, I know that looks sort of like a B, so we'll make it look more like a L. There we go, that's better. Is going to be 35.0 centimeters squared. I knew I shouldn't have put the 0.0 there. I just knew it. All right, that's better. And I got that. And I've got that the perimeter, well, let's see, the length is equal to
2W plus 3.
2W plus 3. 2W plus 3. Okay, so can we guess that one? I guess not. Maybe we could. Okay, well, I just go and take the L and put it up here and say 2W plus 3 times W is 35. And then I'd have 2W squared plus 3W minus 35 is 0. And then I'd probably factor it. Because I'd expect whole numbers, right? This is just number 3, so I wouldn't expect any fractions or anything. 2W, 7 times 5, right? So if I had minus 7 plus 5, that would give me what I was looking for is equal to 0. That gives me minus 35. That gives me 10 minus 7 gives me that guy. Okay, so my width is one of two numbers. It's either 7 over 2 or it's minus 5. All right, what do you think about the minus 5 answer?
That's correct.
Huh?
That's correct.
Yeah, it sucks. Get rid of it. It can't be minus 5. Okay, so this is a real piece of metal. It can't be minus. Don't give me that was correct. So the length is 2W plus 3. So length is 2W plus 3. So that would be sort of like where the plane is if you pick the minus 5 answer. And we're making a video of this. No one's going to know what that's reference is next year, right? So that'll be really cool. Hey, you guys, figure out that reference, okay? L is equal to 2 times 7 over 2 plus 3. That looks like a 10 to me. Does that look like a 10? Okay, so on 10, 10.0, because I have 3 significant digits, centimeters by, what was the other guy? 1, 2, 2.5, 3.5, 3.5 centimeters. Final answer. No, you got to throw away the negative answer because it's a real piece of thing. So you don't have a choice there. Unless, of course, it's a circuit analysis problem and you have negative resistance, and that might very well be, that could happen. Number 7, a variable electric circuit is given by the formula. Okay, so the current is T squared T squared minus 7T plus 12. Have you ever had an electric circuit that did that, had a current that looked like that? Is it even possible to have a current that looks like that? If T is given in seconds, at what times will the current equal 2 amps, 0 amps, and 4 amps? Isn't that lovely? So I got 3 different problems. Okay, so my first problem is 2 is equal to T squared minus 7T plus 12. And so I would have T squared minus 7T plus 10 equals 0. And I could factor that. So I will. T minus 2T minus 10 equals 0. So in this particular case, my T could be a 2 or a 10. In each case, those are in seconds. So I should probably say seconds. 2 seconds and 10 seconds. Okay, looks good. No, we still need a bracket on the other side. Well, that was a lousy bracket if I ever saw one. Okay, so the next one is 0. So if I have 0 is equal to t squared minus 7t plus 12, then I can factor that too. So I'll factor that. T minus 3t minus 4. Well, if someone went all out to get a problem that was this easy to solve, you know that, don't you? And someone sat down for a piece of paper and a pen for a long time. Either that or he stole it from some other book. Probably what happened. Okay, so 3 seconds, 4 seconds. All right, so next part of the problem. 4 amps. For 4 is equal to t squared minus 7t plus 12. All right, there we go. Okay, so 0 is equal to t squared minus 7t plus 8. That's not going to factor, is it? Bummer. Yeah, it is. That's going to. No, that's not going to. No, not that. No. Ben's telling me it doesn't factor, so it's not going to factor. Okay, so I can't factor it. Why don't we use completing the square? What do you think?
Sure.
Sure. No, why don't we just put it in our calculator? That'd be better. Okay, you guys put it in your calculator, and I'll complete the stupid square, and we'll see who gets the right answer first. So I got t squared minus 7t plus 7 over 2 squared is equal to 8 minus 8 plus 7 over 2 squared. I got t minus 7 over 2 squared is equal to 8. 4 times 8 is 34, right? 32. 32 over 4 plus 49 over 4. Okay, I take the square root of both sides, and I have t minus 7 over 2 is equal to plus or minus the square root of 17 over 4. So I've got t is equal to 7 over 2 plus or minus the square root of 17 over 2. All right, so 7 over 2 plus the square root of 17 divided by 2. So I got 5.56. And then I got 7 over 2 minus the square root of 17 divided by 2. And I got a 1.44. All right. So is that what your calculator told you?
Yep.
Okay. Excellent answer. Whether or not that's the correct answer is beside the point, but the class answered properly, telling the instructor he was correct. All right. All right, so what are we doing next? That was 7. Oh, 8. All right. Number 8. I have a variable voltage. Voltage is equal to my t squared minus 14t plus 48. Now, can I have a voltage that looks like that? Probably not. So that's probably a made-up voltage. And again, we got to do it 3 times. Okay, so the first time, V is equal to 3. So if V is equal to 3, then I'm going to have t squared minus 14t plus 45. 45 is equal to 0 on that factors. That's nice that it factors, right? T minus 9, t minus 4, t minus 5, the other 4, yeah. All right, t minus 5. Just seeing if anybody's awake out there. So in this case, t is going to be in alphabetical order 5, comma 9. All right, so there we go. 1 down. Next problem. T is equal to 35 volts. All right, so I have t squared minus 14t plus 13 is equal to 0. And of course that factors, so we'll just factor that. T minus 13, t minus 1. And they should all be this easy, right? And you guys would do so much better because you're not using a smart board. T is equal to, we'll call it 1 and 13. 1 and 13. And I should probably be putting seconds in there, right? But I'm not. And the last part of the problem says I'm equal to 4. No, it's not. I'm equal to 0. So 0 is equal to t squared minus 14t plus 48. Now, does that factor? That's 48 would be 6 times 8, right? And 6 and 8 is 14. Well, that factors too, so I don't even have to use a quadratic. I don't have to complete the square on it. Oh, bummer. Not that I would. I might. Just for the heck of it or whatever. Okay, so 6 seconds, 8 seconds. There, I put in seconds this time. Everybody happy with that? Voltage. Oh, number 9 is charge. That's even better. Number 9, charge. The charge is given by a formula. Q is equal to 2t squared minus 4t plus 4. And again, we're going to ask the question: could I have a charge that does that? And the answer probably isn't. We want the answer in milliseconds when Q is 2. When Q is 2, is that a lot of charge? See, one lousy electron is 1.6 times 10 to the minus 19th coulombs. So 2 coulombs, that's a lot of charge. Yeah. Anyway, back to the formula. I've got 0 is equal to 2t squared minus 4t plus 2. And I look at that, and I might be able to factor that. Oh, well, I just change it to divide everything by 2, right? T squared minus 2t plus 1. Oh, well, that don't have to think about it. T minus 1, t minus 1 is 0. And the charge in coulombs, blah, 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 find t in milliseconds. Find t in milliseconds. All right, if you say so. 1 times 10 to the 6th millisecond, microseconds. The other microsecond. That's better. Microseconds. So that seems kind of weird. And then we'll do it again with q equal to 3. So I'm going to have 0 is equal to t squared, 2t squared, minus 4t plus 1. I don't think that factors. So what do you think? Half quadratic formula? Okay, well, so we'll use half quadratic formula. Say 0 is equal to 2t squared plus 2 times minus 2t plus 1. And I'd probably just do that in my head. I probably wouldn't write that down. So t is going to equal 2 plus or minus square root of 4 minus 2 divided by 2. So it looks like 1 plus or minus the square root of 2 over 2. Is that what it looks like to you? All right. And we'd probably just leave it that way. Microseconds. Yeah. That's probably what we do. All right, work, we don't care about work, but we do care about magnetic fields in Webers. So number 11 looks like that's sort of like in rate. So number 11. So the magnetic field varies. Does the magnetic field of the Earth vary any? Or is it a constant type of thing? Minus 2t squared. Actually, it changes. Changes directions, changes all kinds of things. So depending on the terrain and what's under the Earth at that point, we'll do things. But it's not that much. All right, find t in milliseconds. Okay, so I've got 0.02 Webers is 0.4 t minus 2t squared. All right, well, let's multiply everything by 100. Minus 200 t squared plus 40 t minus 2 is equal to 0. Oh, well, that was just so Marby. What if that factors? Maybe I can factor that. Think I can factor that? If I put it in my calculator, then I'd know the right answer, and I wouldn't have to factor it. If it were 8 times 25, and then I multiplied 2 times 8 and got 16 and added it to 25, I still wouldn't get 40, right? If it were 10 times 20, there we go, 10 times 20, and then 2 times 10 is 20, and 20 plus 20 is 40. Okay, so this is going to be 10 t, 20 t, We'll put a minus sign there. We'll put a plus 1 there and a minus 2 there. And then we can factor it. All right, well that was easy. Okay, so t is equal to, and 2 divided by 20. 20 divided by 2, 1 over 10. So it would be 1 over 10. And, but we want our answer in what? In milliseconds. Okay, so we don't want 1 over 10. We want 10, we want 100. 100 milliseconds for the first answer. And the second answer would be 1 over 10. It'd still be 1 over 10. All right. 100 milliseconds for both my answers. All right. So I have a double answer of 100 milliseconds. Excellent. Perimeter, rectangle. We have to do 15, so I guess we'll go and do 15 next. A square 4 inches on a side is cut out of the corner of a square sheet of aluminum. Okay, so here I got this square sheet of aluminum, okay, and I cut out a square right there, 4 inches on a side. And I'm sure I'm using some laser whatchamacallit thing. The sides, a square of each corner. Okay, so I'm going to cut out a square of each corner. Boom, 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 boom. That's even better. Okay, square of each corner. The sides are folded up to form a rectangular container whose volume is 400 inches cubed. What was the size of the original sheet of aluminum? Okay, so I've got some L here, and I've got some L there, and I got some L there, and I got some L here. So L squared times 4 is 400. Yeah, 400. Clearly implying that L is 10. So the original piece is going to be 18 by 18. So final answer, 18.00, 18.0 inches by 18.0 inches, because I have 3 significant digits.
That was 400 cubed though, correct?
Yeah, and this squared times 4 would be inches cubed. So L is in inches, and I square it. And 4 is in inches, so that this is inches cubed on that side. Yep. Yep. No loss in generality there. So what do you think? You want a different answer?
No, I was going the roundabout way and getting nowhere, so that's I was trying to.
Well, okay. Well, that would be okay to do. You know, Robin Hood's barn is always a good place to go around to get the right answer.
Because if you look in the front, it shows volume is length times height times width, which is all 4 the same. I understand now.
Well, no, length times height. So length would be that.
Right.
Height would be 4 inches, and L would be the width.
Right.
Yeah. So it'd be L squared times 4. Yeah. So I should have brought in a piece of aluminum and folded it so you get a better visual picture of the situation.
Yeah.
Yeah, exactly. So I have something that looks like this. That's L on each side, and then when I look this way, on 4 inches, and on L looking like in that way. Okay, is that better? Yeah, I agree. The better the picture that you draw in your mind or on your piece of paper, the better chance of getting a correct answer. Now, because this is 15, you do have the option of looking at the back of the book and telling the answer, telling the instructor it's wrong, right? Whether he is or not is irrelevant. You can still look in the back and say it was. Square cut rectangular field, projectile. Do we care about projectiles? How wide is a strip? Wide strip, horizontal there. Cross-sectional area of that. Okay, so we'll look at 22. That looks funny. 22. The cross-sectional area of an L-shaped beam is 24 inches squared. What is the thickness of the metal? Okay, so 8 times x. Well, that's bad. Put a times and use x both. Times x times 6 minus x times x is equal to 24 inches squared. And we better put a plus sign right there. Okay, so we have 8 times x would be the area of the 8-inch guy, and then the area of the 6-inch guy would have to be 6 minus x times x, and that all is going to come up to 24. Alright, so now that I got the equation correct, now I can say that 8 and 6 is 14x, and I can say that that's minus x squared plus 14x minus 24 is going to be 0. And then I'd ask myself, can I go and factor that? And the answer is yes, I can. So I could have x and an x. And I could have a minus x and a minus, and a minus 12 and an x plus 2. I could do that. Is 0, in which case x could be 2 or x could be 12. Now, can x be 12? No, x cannot be 12, because if x were 12, that's bigger than 6. I wouldn't have an L-shaped beam anymore, right? So I would get rid of that one. Boom. That does not make sense. So my final answer, x is equal to 2 inches. Okay, then we'll check our work. 2 times 8 plus 4 times 2 equals 24. Check. Go ahead. Excellent. Area of rectangle, equivalent resistance of 2 resistors. Okay, 25 is next. 25. The equivalent resistance of 2 resistors, okay, so in other words, resistance total. Resistance total is 45 ohms. If the resistance of one resistor is 3 times that of the other resistor, so I have resistor 1 is equal to 3 times resistor 2. what is the value of each resistor given that resistance total is that, where R is that and blah, blah. Okay, so that being the case, I have 45 is equal to R1, R1, which is 3 times R2, times R2 divided by R1, which is 3 times R2, plus R2. All right, so I got 3R squared, R2 squared, 3R2 squared divided by 4R2. Okay, so I multiply by 4 and I divide by 3. If I divide by 3, I get 15. If I multiply by 4, I get 60. So 60 R2 is equal to 3 R2 squared. All right, so I've got 3 R2 times R2 minus 20. 20 is equal to 0. So did I skip enough steps? I put that on the other side of the equation. I factored out the 3. I factored out the R whatever. And in so doing, I get R2 is equal to 20. Okay, well, if R2 is equal to 20, then R1 has to be 60. R1 has to be 60. All right, now what do we know about that answer? We know that it is wrong, right? So we just take out our red pen and say, that's wrong. What did I do wrong? Why is it wrong?
RT is going to be it's going to have less resistance than the lower.
That's right. So the total resistance has to be less than the smallest resistor, so that can't be the right answer. So we just cross it out and say, no. And so now the issue is, do we look to see where we made a mistake, or do we do something else? All right, so 45 is equal to 3 times that.
Which is divided by the total resistance.
That is the total resistance. That's R1 plus R2.
Well, then you have 45 as your total.
Yeah, isn't it?
Yeah. So you can put R.
No, the formula that we're using for parallel resistance is total resistance is equal to the two guys multiplied together divided by the two guys added, which is the correct formula. This is the correct formula. So, yeah, we'll move back. So you're used to 1 over R total is equal to 1 over R1 plus 1 over R2, right?
Yeah, that's what I was thinking.
Yeah, that's what you're thinking. But I got a common denominator, right? So this is R2 over R1 R2 plus R1 over R1 R2, which is R1 plus R2 over R1 times R2, and that's 1 over. So I put everything 1 over, and your total resistance is resistor 1, resistor 2 divided by resistor 1 plus resistor 2. But that doesn't so the issue is I think we just go and start all over.
Okay.
That's what I think we're going to do. Okay, so the total resistance is 45. Okay, so 45 has to equal number 25. And if one resistor is 3 times the other resistor, okay, so R1 is 3 times R2. Okay, resistor 1 is 3 times R2. So I'm going to have 3 times R2 times R2 divided by 3 times R2 plus R2. So I'm going to have 45. I think I'm doing the same thing over again. Am I just doing the same thing over again? 3 R squared, R2 squared, divided by 4 R2. Alright, so I'm going to have 45 is equal to 3 over 4 R2. Right, because I can go get rid of R2 there on both sides. So R2 is equal to 3 goes into 45 15 times, it says 60 ohms. What did I get last time for R2? So if R2 is 60 ohms,
20 and 60 didn't get the last time.
so if R2 is 60 ohms, then R1 has to be 3 times that amount, 180 ohms. There, that's much better. Now I'm gonna dumbly put it in my calculator and see if that's right. 1 divided by 60 plus 1 divided by 180 equals well, that was good. 1 divided by, close parentheses. All right, 1 divided by 60 plus 1 divided by 80, 180, close parentheses, boom, 45. Okay, so we did a check and we found that our total was 45 and everything is okay. All right, so we can do the problem correctly. So now that begs the issue, what did we do so wrong up here anyway? That's what we did. No, that's not what we did. Yeah, well, this is over R2. And that 3 went away. When I took the 3 over there, I put the 4 over there, I multiplied the 3, and I left the 3. All right, well, that was pretty silly. And then those 2 goes away. So if I would have done it right the first time, I would have gotten R2 was equal to 60 the first time if I wasn't so much stuck on doing it wrong on purpose. 28, the parking lot problem. I remember this one. Maybe I can do it in 4 minutes. If I can't, you guys can just do it on your own. Find, see, a parking lot is 200 by 100 meters. It is to be tripled in area by adding the region as shown in 7.7. Find X. Okay, so I've got 200 by 100, and I'm going to triple that. Okay, so that looks like a 6 with 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros. Meters squared. So that's 60,000 is going to equal 200 plus 2x. So that's one side, 200 plus 2x. And the other side is 100 plus x. The other side is 100 plus x. All right. So I have to do this right the first time. I can't goof off. So I've got 60,000 is equal to a 2 with 4 zeros. 1, 2, 3, 4. Plus, I have a 2x squared. I got a 200 and another 200 plus 400x. So I got 2x squared plus 400x minus 40,000 is equal to 0. I can probably factor that, but I'm not going to even try. I'm just going to put it in my calculator and see what it says, because I haven't done that yet today, right? Polynomial solver. So I got a 2, I've got a 400, I've got a minus 40,000. And it says that x could be 73.2, or x could be minus 273.2. Well,
It's not negative.
huh?
We know it's not negative.
We know it isn't negative, so we'll get rid of that guy and say the negative guy is wrong, and we'll circle this guy here as our final answer, but we're going to want to put meters next to it, which begs the issue of whether or not I could have factored that. Right, so if I had x squared plus 200x minus half of that, 20,000. Yeah, I don't see that factoring too well. So I'd have to use quadratic formula or something like that. And if I'm going to use the quadratic formula, I might as well use my calculator. All right, good enough? So the plan says review for the test tomorrow, test on Friday, which means you don't have a quiz Friday. What a bummer. I know. I know you're disappointed. No quiz on Friday. I'm disappointed with that too.